Hello, algebra students. Mr. Lawrence here, and this is your one video you're required to watch. Now, there's no video quiz at the end of it per se, like one I'm not going to collect, but what you need to do is at the end of this video, there's going to be 3 problems imitating, doing exactly what I did. I want to see your answers to them when you come in on Monday, January 5th. So make sure you have them in your notes, okay? And show me those answers. All right, so we're going to be simplifying radicals. Now, first of all, let's get one thing straight. We're not talking square roots here. We're talking radicals. They look exactly the same. The only reason you know that they're different is because I'm saying the word radical. A radical means the positive square root. Okay, the radical is the positive square root. So like, Mr. Tarbuck, you had to push a lot of floor, right? So, sorry about that. I got emails popping up here. Let me shut that down. When I ask you the square root of 25, you tell me 5. No, that's not correct. It's 5 or negative 5, right? When we're dealing with a radical, we're only dealing with the positive of the 2 square roots. So it's important to remember all positive numbers have 2 square roots, but radicals, we're only dealing with the positive one. Okay, now I'm going to show you how I think about this, but before I do, you really want to make sure you know your perfect squares. I've talked about this many times. 1, 4, 9, 3 squared, 4 squared is 16, 5 squared is 25, 36, 49, 64, where are we at here? 981, 100, thank you. Okay, and then 11 would be 121, 12 would be 144, ooh, that's gross, 169, 196, hey, wow, look at that. Something I never noticed. 1 and 11 end in the same one, 2 and 12, and that's pretty cool. 15 will be 225. 16 will be 256. 17 is 289. 18 is 324. 19 is 361. And 120 is 400. Okay, buddy, I'll be up there in a minute. Close that door all the way. Thank you. Okay, I would know my perfect squares. They're going to make this, doing what we're doing, so much simpler. Make flashcards out and quiz each other instead of, screwing around in study hall. Take the time to learn. Okay, now we're going to do a real simple one here. Square root of 25, the radical of 25, excuse me, is 5, because 5 times 5. Well, I actually like to break that down. I like to go like this. And then I like to think of the numbers as people, and the square root symbol as a house. And normally, 2 people go out on a date. So you see, these 5s match each other. They're a good fit. They go out on a date. They leave the house, and that's why it's 5. Nothing's left inside. No one's left inside the house. Now, if I try to do the square root of 50, I'm going to think about it, the radical of 50, excuse me, I'm going to think about it as 25 times 5. And then I'm going to think about it as 5 times 5, right? Well, look at this. I got a pair of 5s. These 5s can leave the house and go out on a date. So let me rewrite this so it looks a little more organized so you don't get confused. All right, so I've got 5 times 5 times 5. Okay, and I'm going to send these 2 out on one date. But this 5 doesn't have a date. He's stuck at home watching TV. There you go. Okay, you see how I'm doing that? I'm trying to break down the number under the radical into 2 factors. It's best if I can find the largest perfect square that's a factor. That'll make it way easier. Okay, then I'm looking to take the square root of just that part of the number. 200 would be an easy one. I could take the square root of 200. Let's see here. What's the largest perfect square that's a factor of 200? Well, how about 100? And then it'd be 2, right? And then 100 is 10 times 10. So the square root of 200 is 10 times 10 times 2. Well, since I'm taking the square root, look at this. I got a pair of 10s. They can go out on a date. Math is going to be very segregated in terms of its dating. 10s will only date 10s, 5s will only date 5s, etc., etc. But there you go. The simplified version of the radical of 200 is 10 times rad 2. Okay? 20. What's the largest perfect square that's a factor of 20? Well, I think it's 4, and it's times 5. And so I can think about square root of 20 as 2 times 2 times 5. These 2's go out on one date, and then we have a rad 5 stuck at home. 2 rad 5, 2 times the square root of 5, positive square root of 5. Okay? I better do a couple more before I give you the problems, just so you can see. Let's see here. I got to erase this. For those of you who don't know, I'm having smartboard connection problems, and so I'm having to use a recorder in Word, and it doesn't work as well. Okay, so not a problem. We will adapt, improvise, and overcome. All right, let's say we're going to do the rad of 72. James told me lunch is ready. I'll be there in a minute.
I'm taking Nicole over.
Okay, great.
James is at the home.
Okay, I'll be there in a minute. All right, rad 72, and how about rad of 90? Okay, now, sometimes we're not going to be able to grab the largest perfect square. Like, I know a lot of you right off the bat, you're going to go, well, 9 works. Yeah, 9 does work, 9 times 8, but 9's not the largest perfect square, because I can think of 8 as 4 times 2, and so you see I have 2 perfect squares here. I have 9 and 4. Now, if I want, I could multiply them together and go 36. Hey, 36 is going to work. Or I can do this. I can rewrite the square root of 72, rad 72, as 3 times 3 times 2 times 2 times 2. The 3 times 3 is coming from the 9s. The 2 times 2 is coming from the 4. And then this 2 is here. Now, I'm going to have a couple of dates here. The 3's are going out on a date, but so are the 2's. So out front, I'm going to have a 3 times a 2. Who's left inside? This 2 doesn't have a partner. He's left there. But 3 times 2 is 6, so the best answer here would be 6 rad 2. That is one way to do it. Okay? Now, another way to do it would have been to, as soon as I realized 9 times 4 would be 36, and 36 is a perfect square, I could rewrite rad 72 as 6 times 6 times 2. There's my date. The 6 leaves the house. 2's left inside, and you see I get the same answer. It's a little more direct. The better you are with your perfect squares and your number sense, the easier these things are. If you refuse to learn your multiplication facts, you refuse to learn your perfect squares, this is going to get harder and harder. All right, the rad of 90. Well, let me think here. I see 9 and 10. I can do 9 times 10. 10's going to break up into 2 and 5, but both of those are prime. I think this is the best way to break it down. I'm going to break this down as 3 times 3 times 10. Okay, I know there's no other dates hiding in here because the only factors of 10 are 10, 2, and 5. And those don't match anybody. So the 3's are going to leave the house. Square root of 9 is 3, positive square root of 9. And it would be 3 times the square root of 10, 3 rad 10. Okay, I think I've done enough examples here. Let me put up the 3 problems I want you to attempt. We'll talk about on Monday, January 5th, and then we will get some practice with it. This should be really pretty easy stuff. So the first one is the rad of 60. The second one is the rad of 108. And the third one is the rad of 45. Okay? And I'm not going to tell you these answers. We'll talk about them Monday in class. Mr. Laurence signing off. Have a good night, everybody.